Okay, we're given that the National Institute of Mental Health published an article stating that in any 1 year period, approximately 8.4% of American adults suffer from depression. So, I'll write this down here. So, P, population proportion that suffer from depression, is, I'm going to write this as a decimal point, 0.084. I'll have to see how Miles of Math wants it written. Suppose a survey of N is equal to 2,000. A certain city has P hat equal to 0.111. Again, just change that to decimal. Conduct a hypothesis test to determine if the true proportion of people in that city suffering from depression or depressive illness is more than 8.4%. So 8 sub 0 is going to be that P is equal to 0.084, and 8 sub A is that P is greater than 0.084. So up here, I was just going to give you the hypothesis testing about a population proportion P. Your test statistic is going to be Z is equal to P hat, which is X is your number of successes divided by N. Subtract P, which is the value given, divided by the square root of P times Q divided by N. Okay. But again, we're going to use technology to do all this for us. Sorry about this. Let me fix this. And we're going to do alpha is 0.01 at 1%. Okay, so our hypothesis, our null, is going to be P equals, okay, it's a use decimals, not percentages. Okay, that's what I'm on, 0.084. And P is greater than 0.084. Okay, our test statistics. So let's go over here to StatDisk. I may have to widen it out just a little bit. Let me see if I can get this one. To get to analysis, okay. Hypothesis testing. Proportion 1 sample. Our alternative, by default, is not equal, so our alternative is going to be greater than. Significance, 0.01. Decline proportion is 0.084. The sample size is 2,000. Now here's where it gets a little tricky. Your number of successes, X equal. They only tell us what P hat is. So that's why I wrote this down. P hat is your number of successes divided by N. So this is where we have to do just a little bit of math. So you have to say, or a little bit of algebra, I should say. So P hat is going to be equal to, again, X divided by N. And we know that's equal to P hat 0.111. So I don't know what X is. So X divided by 2,000 is equal to 0.111. So let's bring up the TI. So you cross multiply. So it's basically just 0.111 times 2,000. Now I haven't run across one of these in my alphabet yet that has a decimal in here. If you do run across one that has a decimal, I'm pretty sure that you round up, but you can email me and let me know if it marks you wrong. So I'm going back to stat disk here, and I'm going to put in that X was 222. Evaluate. Slide this over. 4 decimal places. Okay. So our test statistic Z is going to be equal to 4.3530. What I really care, and that's a pretty high Z value. P is 0.000120, the 4 decimal places. Okay, so let's go here. 4.3530. 0.0000. So obviously, and I'll come up here and write it. At alpha equal to 0.01, P is less than alpha. Therefore, I reject the null in favor of the alternative. And conclude ... Okay, so let's go here. We're going to... Yeah, I gotta get myself some more RAM here. Reject the null. There is enough evidence to support the claim that it is more than 8.4 by far. Submit. Let me know if you have any questions. Thanks.